So we've had the law of sines, and we realized from our last series of videos that we needed to know uh, something else in order to use to solve side-side-side triangles or side-angle-side triangles. In other words, triangles in which we don't have and can't easily find a corresponding angle and side. So in those cases, we need the law of cosines. Law of cosines is going to start off with a triangle, and we're going to put it on the coordinate axis with A at the origin. So A is at 0, 0. And when we do that, we can then say that point B is at, or angle B is at the point C comma 0. And that's because the x value is whatever this length is, C, and the y value is 0 if we're on the x-axis. We can also build a right triangle using, we talked about altitudes. If we build an altitude up to C, we see that we have a right triangle, and using our trig functions, we can recall that our x value will be b times cosine A, and again that's because our angle A and our hypotenuse B, and our y value will be b sine A. So that gives us this point up here, b cosine A, b sine A. And we can use those 2 points along with the distance formula to find the length of A. So our distance formula says it's the change in your x values squared plus the change in your y values squared. All of that is the distance squared. So otherwise you could take the square root of all that and find the value of the distance. Now in this case we've got A is being squared, and we've got the distance on our x values is the distance between b cosine A and C. We'll square that. The change in our y values is the distance between b sine A and 0, so we'll square that. And when we go ahead and multiply out this binomial, the b cosine A minus C, we get b squared cosine squared A minus 2bc cosine A plus c squared, and then the b squared sine squared A. Notice I've got a b squared sine squared A and a b squared cosine squared A. So if I gather those up and factor out the b squared, sine squared plus cosine squared is just 1. So that gives me a squared equals b squared plus c squared minus 2bc cosine A. This is our law of cosines. By rotating this triangle around, we can determine that this also holds for the other 3 values, and that gives us that a squared equals b squared plus c squared minus 2bc cosine A. Similar relationship for b squared, similar relationship for c squared. You might notice that the bottom one looks a lot like the Pythagorean theorem, and in fact it is. Pythagorean theorem is actually a special case of the law of cosines. It is the case where angle C is 90 degrees, because cosine of 90 is 0. So this last part goes away, and we end up with just a squared plus b squared equals c squared. Another way you could look at it is that the law of cosines is the Pythagorean theorem with a little bit of a correction out here. The minus 2ab cosine c is just, it adjusts to make up for the fact that that angle is not 90 degrees. Now, sometimes we'll be looking for this. This is the way we would use the law of cosines to find side angle side. We would use it to find the third side. So if we're given a B and a C and a capital A, we'd use the top version. Sometimes though we're given a side-side-side triangle, and in that case you could plug the values in here and then solve it for cosine A, or you could just solve it for cosine A, and that's what I've done in this version. It's for when you're looking for an angle, you can plug in the 3 sides that you know, and then you'll use the inverse cosine function to find out what the angle is. Now one thing I will point out, cosine, remember how sine we had the ambiguous case where we didn't know is it supposed to be an acute angle or an obtuse angle, because sine of 100 is the same as sine of 80. That's not the case for cosine. Cosine, the inverse cosine or arc cosine, will give us back obtuse angles. So it's best, if you're looking for an angle, to start with the largest angle. Now, how do we know which one's largest if we don't have any? Well, we already know that. We know that the longest side will correspond to the largest angle. So whichever our longest side is, we'll find that angle first if we're looking for side, side, side. So let's do some exercises.